All right, so go ahead and read your warm-up, please. And tell me what you think. Why would a linear function not model the sale of video games well? What do you think? Fourth period knocked us out of the park today, actually. Go ahead. Yeah, if it's a line, it's consistent, right? It stays the same, going up the same amount or down the same amount. So why would that not be good for video games? Do video games do that? What happens? Go ahead, Savannah. Yeah, what happens to the sales of video games the day they come out? They shoot up and they have a peak. What is a peak? What is our math term? What's our math term for that? No. It's an extrema. It's a maximum. Is everybody okay with that? When else do video game sales go up quite a bit? When do people buy a lot of games? What time of year? Christmas. You guys ask for video games for Christmas. Black Friday. Okay. That is not consistent. Okay. That is not a good representation for a line. It would be a curve, and that curve would have maxes and mins. Okay. What's that? Your birthday? You get video games? Okay. So I need you to write me a nice cohesive sentence there that says something like that. That video game sales would not be represented by a line because lines are consistent. Lines are consistent. Okay. Game sales would spike when they are brand new. They would spike at Christmas time. Something of that. Okay. Please don't start with the word because either. Okay. It should be something about video game sales would not be a good representation of a linear function. And then you can put the word because, but we're not going to start a sentence with because. A week and a half off? What, for the rest of the year? Right. Oh, well, I won't give you homework over Christmas break if that's what you're asking. For one day? Okay, deal. One day. The first day you come back from Christmas, you will not have homework. Deal? Okay. It's on a recording. It's there forever. Oh. Oh. I don't know about that. I'll do the one no homework. The first day you come back. Okay? All right. Does everybody have a sentence written? Yes. Describe some points or areas on a graph of video game sales that might be of more interest to someone in the video game industry than other points. So let's say I'm the owner of this big video gaming company. If I'm looking at a graph, what parts of the graph would I be interested in? The high and low points. I want to know when are sales peaking, right? I want to know when are sales really low, because then maybe I can amp it up for those times that are really low. Or maybe I can try and duplicate those times that are really high, yes? What else might I be looking at on a graph? Besides really high points, really low points? No, not really the start and the end. Okay, if it's dropping, what is it doing? It's decreasing. I want my sales to be increasing, yes? So I would be good with whatever I'm doing when my sales are increasing. But if they're decreasing, I might want to try and fix something about it. Does that make sense to everybody? Okay, so go ahead. Write yourself a nice cohesive sentence that talks about how you would want to find where the maxes and mins are. If you were really good, you'd use the word extrema. Okay, and where that function is increasing and decreasing. When you are finished with that, please open up your Chromebooks. We are not, I repeat, we are not going to complete the self-check, okay? We're going to go right to the middle where it says notes. Right to the middle where it says notes. And I actually need to fix this a little bit here. No, we're using it. Yeah. No, we're using it. But I do need to fix something about this real quick. Okay, so if you will please follow these directions. Excuse me? I just didn't hear you, was all, Tyler. Yeah, but I had to change it a little bit. The terminology has changed a little bit for Google Classroom. You don't have an About tab anymore. It's actually called this. So can you do that? Go to Google Classroom, click on your classwork tab, click on the graphing calculator, which is called Desmos, and then just go ahead and wait. So here's your classwork tab. You should be going to this graphing calculator that says Desmos. Now, I've already done this before. Once you get to here, you see this red button? If you click on that red button, it takes you where you want to be. Now, I would highly suggest clicking that star right there and making it a bookmark if you haven't already. So what will happen is, everybody see this green little box right here? That's Desmos now. So I don't have to go through my Google Classroom anymore. I just come in and I click on that and it'll take me right there. Yep. Desmos is awesome. It is amazing. Okay, we're going to use this a lot. Now, I need to remind you that I have my notes and my Desmos all on this screen. You guys have your notes next to you to write and then your screen to look at. So I'm going to be flipping back and forth between screens. I might ask you guys to help me rewrite some stuff, okay? Is everybody clear on that? Okay, so let's take a look at our first example here. Does anybody have any trouble getting to Desmos? Everybody was there? Yes or no? Okay, so first of all, my directions say to graph. Well, that's where Desmos comes in. Does everybody see where this says y equals 2x plus 3? You're going to go to Desmos, and over here on this rectangle, you're going to type in your equation. Y equals 2x, was it plus 3 or minus 3? Plus 3. And that should show up on your graph. That is the graph of this equation. Does anybody need help typing that in? You can either use your keyboard, or you guys all see this little button down here? See this little button? If you pop that up, it has your keyboard. Okay, anybody have trouble getting this graph? Does everybody's graph go up the way mine does? Doesn't matter what color it is, okay? But here's what I want you to understand. Right now, my graph goes by twos. Does everybody see it? If I click this plus button, it will zoom in, and now it goes by ones. If I click it again, it'll zoom in, and now it goes by halves. I'm going to zoom it out with the minus button until it goes by ones. Also realize you can click right on this and you can drag it wherever you want it to go. How are we doing, guys? Still okay? The other thing you can do is up here in this little corner, you see these little arrows? See these little arrows up here? If I click on that, it's going to make my graph bigger and hide my equation. Everybody see that? And then if I click the arrows again, then it brings my equation back. Does anybody have any questions on that so far? It's amazing. Okay, so let's actually answer this question now. It says, give 3 solutions to the equations. Now, folks, I don't know if you remember or not. I hope you do, because you're going to have a test over next week. But in section 1-5, we talked about solutions. How do you know if something is a solution to an equation? Let's say I give you an equation and I say, is 4 a solution to this equation? How do I tell if it's a solution? What about the variable? I would plug it in and it would have to equal what it's supposed to, yes? Well, if you look at our equation right here, I have 2 variables, don't I? An x and a y. Well, where do I find x's and y's on a graph? At a specific point. So I need to find points that are in this equation, and those all happen on this line. How many points are on this line? Infinite. There are infinite points on this line. If you click on it, they will give you 2 specific points. Does everybody see that? But I can take and I can drag a point, and you see all of those points that are possible here? Does everybody see that as I drag it? Yeah, there are infinite points, meaning there are infinite solutions to this equation. Now, they give me 2 of them right here, don't they? Okay, so can you tell me 2 solutions to this equation? Tell me, what are they? Negative 1.5 comma 0. And what's another one? 0 comma 3. How's everybody doing there with those solutions? Does anybody have any questions about those solutions? No? How many solutions did I ask you to find? I asked you to find 3. Go back to your graph. Can you find me another nice point? And by nice point, I mean whole numbers, or like maybe halves would be okay. Quentin, what do you got? Negative 1, 1 is right here. Is that a point on this line? It is. So is it a solution? It is. So let's go back and write negative 1, 1 in here as well. Now, let me prove to you that these are in fact solutions, because you just told me if it's a solution, that means when I plug it in, it works, right? Okay, well, let's plug this in. Let's just do negative 1, 1. Is that okay with everybody? You don't need to write this down. I just need you to pay attention and watch. Okay, first of all, what's my y? Does everybody see this? This is the x, this is the y, right? So the y is 1 equals 2 times what's my x? And then plus 3. Let's see if it works. Got your calculator? 2 times negative 1 plus 3 equals 1. That's what it's supposed to equal, right? So it is, in fact, a solution. Now, are these the only 3 solutions possible? No, there are infinite solutions that you can find. Questions for me here? Okay, I want to go back to this graph real quick, and I want to talk about a few things. I want to know, what's the x-intercept? Do I have a point where that happens here? What is it? Negative 1.50 is the x-intercept. What's the y-intercept up here? 0, 3 is the y-intercept. Tell me, is this thing increasing or decreasing? So it's increasing everywhere, and it's decreasing nowhere. Does this thing have any extrema? What does extrema mean? Highs and lows, peaks and valleys. I don't see any peaks or dips or anything like that. Do you? Because what kind of a graph is this? It's linear. Is everybody following me? Next follow-up question. Where is this thing positive? Where is it above the x-axis? What's that? It's 0 right there. I want to be above 0. It would be after all of this is positive, isn't it? So that's after negative 1.5. Where is it negative? Before. All of this is negative. That is before negative 1.5. You guys did great. How is this? Okay? Ready for the next one? Okay. So you're going to hit this little X up here. And I'm going to go back and look at my notes. Now, does everybody see how this says f of x? You can type in f of x right into Desmos. It'll work. F of x equals, now, that says negative a half, doesn't it? When you do a fraction, you're just going to use your divided button. 1 divided by 2. Now, does everybody see how my cursor is still in the bottom of that fraction? You have to push the over arrow to get out of the bottom of the fraction. And then I'm going to hit my x. And then what was on the end of that? Plus 3. Okay, does anybody need help creating this graph? How'd we do? Anybody else see how? Okay, you're welcome. If your graph is not showing up, you might have to zoom in or zoom out, okay? Or drag it so you can see it. Is that all right for everybody? Yes, no, maybe? Okay, let's ask a couple questions before we write down some answers here. Are you ready? Where is this thing increasing? Where is it increasing, going up? It is not increasing at all, is it? Folks, look at it. It's all decreasing, isn't it? So it's decreasing everywhere. Okay, what is the y-intercept? 0, 3. Make sure you get it in the right order, okay? What is the x-intercept? Okay, is this linear or nonlinear? It's a line, so it's linear, right? Does this thing have any extrema? It does not. Okay, where is this thing positive? Not everywhere. Where is it above the x? It is before 6. That's all positive above the x, right? Did everybody see that? Before 6, the 6 right here, everything before that. Why are you looking at me funny? If it's positive, it's above the x, yes? Where is this line above the x-axis? All of this is above the x-axis. That is all happening before that number of 6. Okay, where is it negative then, guys? It's negative over here, which is after 6. Still doing okay? Are you ready to give me some solutions now? Well, the 2 of them are right there, aren't they? Okay, so I'm going to need you to read those to me, please. 4, 1, and 2, 2, you say? Now, I only need 3 of them. How can I check to see if they actually are solutions? Plug them in. Let's try it. I'm just going to do this last one right here. If I'm going to write this in, that says f of x up there, doesn't it? What is f of x the same as? Y. You all see how this y is right here and the f of x is right here? They're in the same spot, so it's the same thing. Okay, let's plug it in. What's my y? 2 equals negative 1/2. What's the x here? 2, and then plus 3. So grab your calculators. Negative 1/2 times 2, negative 1/2 times 2 plus 3. Negative 1/2 times 2, then plus 3. You should get this number right here. Did you get that number? Yeah, you did, because it's a solution that's on the line. We doing okay? Sure? Okay. Let's go over to the next one. Now, this one has h and a instead of x and y. Can we rewrite it, please? Can you rewrite this with x's and y's? Did you just say this is going to be that u thing? You rock. Yes, it's going to be a parabola. That's awesome. We'll get there later for the rest of you guys. Okay, how do I rewrite this, folks? What's this h of a? What's this part right here? That's f of x, which is the same thing as, okay, h of a, don't give up. H of a is the same as f of x, which is the same as y. You see how they're all in the same spot there? Okay, so this is y equals 2. Now I'm not going to use a's. What am I going to use? X's, 2x squared minus 4. You can do it with the a. Will it still do it, the h of a and the a? Yeah, go for it. Here we go. I'm going to need you guys to read this back to me once I get here. All right, y equals, what do we got? X. Now, folks, does everybody see the squared button here? Squared, and then minus 4. It's a parabola. It's a U shape. Is this thing linear? No. Does it have any extrema? Yes, it does. It has a minimum. Where is that minimum? Yep, right there, and it tells you that point, doesn't it? How many times does this thing cross the x-axis? Twice. Now, folks, these are not nice points. Those are big old decimals. We're not going to use them, okay? I want you to find me some nice points. He says -2, 4. Oh, wait a second. -2, 4, which would be right here. You guys agree with that? And then you said +2, 4. Well, that's funny. How come they're both like right there? The thingy, they're the thingy. They are symmetrical, folks. If I draw a line right here, does it cut that thing in half? It is symmetrical. Okay. Is this thing a function? Does it pass the vertical line test? Put a vertical line on your graph. Does it pass the vertical line test? It will never, that vertical line will never touch that graph at more than one point, will it, at the same time? So it passes the vertical line test. This thing is a function. I got a couple more follow-up questions for you. Where is this thing positive? Correct. Where does that happen? It's actually not above at that point. That's where it starts being above. What would we call all this? That's before. Okay, it's not confusing if you look at your number line. Look up here, Tyler. That is -1.41, right? Numbers that are before that, all of these are before that, right? That's why we say before this number. If it would be after it, it'd be on the right. Like over here. Does everybody agree that this would be after that number? Okay, so then where is it negative? Between what? Yeah, that's between those two numbers, isn't it? How we doing? This is what you're going to have to do on your homework. Okay. One more follow-up question. Where is this thing decreasing? No. Where is it decreasing? Before 0, -4. Got it? Where is it increasing? It is increasing after 0, -4. Make sense? Okay, now let's actually go back and answer that question. And I think you guys already did that for me. Say it again. Like that. Which one are we going to test out and make sure it actually works? 2, 4. He wants to try this one right here. Okay, so what's my y? Equals 2 times what's my x? I think you told me to choose the positive 2, didn't you? 2, 4. Okay, squared minus 4. Grab your calculator. Type it in exactly how you see it. 2 parentheses 2 parentheses squared minus 4. Hopefully it equals this number right here. Savannah says yes. Trevor says yes. Quentin says yes. How we doing, guys? We're okay? Okay. Ready to move on to the next part? The only thing that is changing in the next portion of problems is instead of giving me ordered pairs for the solutions, I want you to give me a table. Tables are the same as ordered pairs, aren't they? Yeah, it's just X and Y. So clear out your graph there, and let's type this one in. Y equals negative 2x plus 5. And again, you might have to move your graph a little bit. We're on number 4. And they're always going to give you your X and Y intercepts, guys. So let's go ahead and put those right in a table. Can somebody read those back to me, what they were? Okay, how's everybody doing? I want 4 of them, though. 2, 1, he says. And 1, 3. Guys, how do I know, standing up here, that you just gave me the right answers when I'm not even looking at the graph? Well, yes, you are smart, but no, how am I checking you without looking at the graph? I'm plugging them in the problem. I can plug this number in right here and see if it spits out the Y, so I know if you're right or not. Does that make sense? If I put this 1 in here, 2 times negative 1 is negative 2 plus 5 is 3, so I know that point is correct. Fair enough? Okay, moving on. Do you guys want to type in f of x, or do you want to turn it into a y? You want to do the f of x like it is? Okay, go ahead. Clear out your other graph. F of x equals, can somebody read that back to me? Now, how do I do x cubed? The AB button is one way to do it. If I put that AB button and then a 3. Now, folks, when I do that, do you see how the cursor stays up in the power? Yes or no? You have to push the over button to get out of the power. You also can use shift and then your 6 key. Your 6 key has that little caret key on it, which is what you use on your calculator, right? So either way you can do that. Now, what's on the end of this? What's the rest of this equation, folks? Now, you might have to move your graph so you can see it. How we do? Anybody need help getting this curve on their graph? Yes, you need help? I don't know how to do the third power? It's this A to the B button. And then you have to hit the over button to get your cursor out of the power. That work? Okay. Folks, we have extrema on this one, don't we? We do. They're right here. Now, this one is not a very nice number. Don't use that. Okay? Not very nice. It's pretty ugly, right? Okay. Can you tell me some points to put in my table? You said 0, 0? 1 and what? Okay, what else? Can you find me some more points? 2, 2? I need one more. You might have to zoom out or zoom in. -1, -4, he says. What do you guys think? Yes or no, guys? Yes? Yes? Can I show you a cool little trick? Sure. In Desmos, okay, so he just told me -1, -4, which is right here, which is good. In Desmos, you see that little gear up there? Yeah, click on that gear. You see this thing that looks like a table right here? Click on it. It'll give you a table. Now, there are 5 points on this table. Are those the only 5 points on this graph? If you click right below that, see how I made it in an empty box there? What number do you want to find the point for? If I put a 4 in there, it'll spit out the answers. So if you go on your graph to 436, there will be a point there. Does that make sense to everybody? Yes, no? Okay, I think I'm going to get rid of this. And I think I've got one more. Yep. Y equals, what are those vertical bars? They're not brackets. They are called absolute values. Okay, so let's go back to Desmos here. We're doing y equals. Does everybody see the little absolute value button down here? Yes? You hit that, it'll start the bars for you. What am I putting in the bars? 2x minus 1. And then I'm going to click out of those bars. Is there anything on the outside or no? No, but it is a V. This is not a parabola. The parabola was rounded. Say that again. Yes. Is it closed? There we go. Everybody all right with this? Okay, I'm going to ask you some questions before we make our table, okay? Are you listening? Where is this thing positive? What you said before. Everywhere. Isn't this thing always above the x-axis? Where is it negative? Nowhere. What is the x-intercept? 0.5 for the x-intercept. What's the y-intercept? 0, 1. Where is this thing decreasing? Before 0.5. Where is it increasing? It's increasing after. Awesome. Do I have any extrema? Yes, I do. Is it a max or a min? It's a min, and it's at 0.5 comma 0. Okay, well, you can either find the points yourself, or you can hit that little gear and find me a table. I think so too, but if it's there, you might as well use it, right? Okay, so what do you give me here? Like this? Are you sure? Oh yeah, that's right. You're good. Questions on this, folks? Desmos is awesome. Okay? If it's straight. If it's curved at all, it's not linear. That V right there is not linear because it's jagged. Okay, your homework tonight. No. We're going to do 2 problems on the back. Okay? You are going to do 7 and 8. You are not going to do 9. I want you to notice the directions. You need to answer A through E for both of those. Now again, you are going to put this on a separate sheet of paper so I can collect it. Do not put it on your notes. You will need Desmos to do this, obviously, because the graphs are not there for you. Does anybody have any questions on what their homework is tonight? Okay.